All right, so again, we're done with the warm-up, numbers 1 and 2. And then number 3, let's do this together, okay? We're going to convert this log to an exponential form. So who can give me the exponential form of this log? Yes, Maddie?
4 to the 5th power
Yes,
equals 1,000.
correct. Okay, any question with this conversion? All right, so again, we start with the base, and then this 5 is going to be your exponent, and that's your answer. Okay? And then what about number 4? Convert this exponential to logarithm. Who can give me the log form? Yes, Ivy? Log, base 15, parentheses 225 equals 2. Or you may not put the parentheses, that's fine, because you only have one number. So that's log base 15 of 225 equals 2. That's right. Okay. Any question?
How many questions are you going to be on a quiz?
You can't tell you that information.
It's a bit.
Just do your best.
Is it on computer?
It's on the computer. Yes. Let's try number 5. Okay. Number 5, we're going to find the inverse of the given log function. Okay. So again, if you're solving for the inverse, it's like converting this to exponential. Okay. So let's start by writing y equals 1/3 log base 5 of x minus 1 minus 6. What is the first step? Switch. Okay. Yes. So x equals 1/3 log base 5 of y minus 1 minus 6. Okay. But yeah, hold on. Now I'm not writing the domain and range yet because you're given the log function. It's easier if we start with the exponential. So once we have the exponential function, we're going to write domain and range and just switch that for the domain and range of the log. Okay? All right. So again, what's the first step? Or the next step? Add 6. Okay? So that's x plus 6 equals 1/3 log base 5 of y minus 1. And then times by 3. That's correct. So I'm going to multiply this by 3 to get rid of the 1/3 at the right side and multiply this by 3. Okay, so this will cancel out the 1/3. And then you're going to distribute the 3 to x plus 6, right? So this is going to be what? 3x plus 18. Okay, you distribute the 3 to both sides. Okay, to both terms. All right, so equals log base 5 of y minus 1. Now, did we isolate already the log expression at the right side? Yes. So we can now convert this to exponential. Yes. So this is going to be our base, and then this is going to be the exponent, and then equals this. All right, so I can write it as 5 to the power of 3x plus 18. Okay, because it's a binomial, I'm going to put that inside the parentheses. And then equals y minus 1. And then add 1, because our goal is to isolate the variable y, because we're solving for y, right? So plus 1, okay? So I can write this. I can just write this directly in the inverse notation, okay? So f inverse of x equals 5 to the power of 3x plus 18, and then plus 1. Okay, this is just telling us that this is an exponential function, and the graph shifted up 1, right? So again, what's the domain of the exponential? All real numbers, so negative infinity to positive infinity. And what is the range given this equation? 1 to infinity. There is no reflection. So we're going to start with the horizontal asymptote, which is 1. Y equals 1, so that's 1 to infinity. Now, since we're asked to write the domain and range of both functions, again, once you have the domain and range of the exponential, it's easier to find the domain and range of the log. Yes, because you just have to flip this.
Wait, Mr. Napaya,
Yeah.
is that the domain and range for what we got or the before?
This is what we got, right? This is what we got. We're solving for the exponential, and we have the exponential form. And again, we always start with the domain and range with exponential. Okay? That's why I started with this one.
How do we distinguish which is which?
If it has an exponent, that's exponential. If it has the log, then that's the log form.
No.
Like what?
For the domain and range. I'm just gonna write this is domain and range for the inverse.
Yeah, you just have to put that on like beside the equation, or you can label them.
That's
Yes.
what I mean. What do I label the domain?
You can just write exponential if you want to label that, and you write that is the domain and range of the log if you want to label it. Yes, but if you put it beside the function, I know that that's going to be the domain and range of that function. Okay, beside the equation. All right. So again, we just have to flip this. So I can write 1 to infinity, and then negative infinity to infinity. That's going to be the domain and range of this function, the log form. Any question? Okay. Now, if you don't have any other questions, then we're going to proceed with number 6. Okay? Now, since you're given the exponential function, so we can now directly determine the domain and range, right, from the given function. So I can just write domain and range first before solving for the inverse. So what is the domain again of the exponential? All real numbers. So since we know that the domain of the exponential is all real numbers, therefore the range of the log will be all real numbers as well. Okay? Domain of the exponential is all real numbers. The range of the log will be all real numbers, right? Okay. Now, what is the range of the exponential? 8 to infinity, yes. Because the k value is 8. So the horizontal asymptote would be y equals 8. All right, so now we just have to solve this. I can write this as y equals 4 to the power of x plus 6 plus 8. So what is the first step once we wrote the equation? Just switch first. Yes, yes. And then subtract by 8, yes. So minus 8, minus 8. So I can write this as x minus 8 equals 4 to the power of y plus 6. Okay. Now, did we isolate already the base 4? Yes. So can we now convert this to the log form? Yes. So what is the base? 4. This is going to be log base 4 of x minus 8 equals the exponent. Okay? So I can write this as log base 4 of x minus 8. Because I have a binomial in my term, I'm going to put the x minus 8 inside the parentheses. Equals y plus 6. Okay? Now, what's the last step? Subtract 6. Okay, can I subtract 6 to the negative 8? No, because the x minus 8 is connected to your log form. So you can write this as f inverse of x equals log base 4 of x minus 8 minus 6. Okay? So this is now our inverse. Okay, so if we're asked to write the domain and range of both functions, again, the range here will be all real numbers, and then the domain here will just be the range from the exponential. Any question? Okay. Then let's say we have the graph. And the graph is not, or the problem is not giving us the base. So we're going to solve for the base as well. Okay? All right, so write the equation of the graph here. Hold on. You sure? Okay. Okay, so first is, we should know the, if it's an exponential growth or decay. Is this a growth or decay? A growth. So therefore, if we're going to solve for the base must be greater than 1. Okay, because it's a growth model. Okay, so it's a growth, so the base must be greater than 1. Yes? Yes, we're going to write the equation or the exponential function of this graph, yes. Yeah.
For this one, I still have like problem finding like if the x is shifted.
If the x is shifted, what do you mean if there's a horizontal shift? Okay, we're not doing that yet, okay? Because again, if we're gonna do that, we're gonna solve for the exponent and we're gonna do the log form, okay?
So So there will never be an
No,
action.
not yet for now.
But not on the quiz.
Not on the quiz, yes, because we didn't do that in class. Not yet. All right. Okay, so we just need to know the transformation, right? So what is the transformation of this graph? What? Okay, let's find the asymptote. The asymptote is this line, right? This is your asymptote. And what is the equation for the asymptote? Y equals 1, positive 1. So that means the transformation here is just the graph shifted up 1, up 1. And then we're also going to figure out what is our A value. So remember last time, we can solve for the A value if we can, find a point on the graph and then use that for your X and Y. But then you can also just, if you know the difference between, or the gap between the asymptote to the intercept, then that's going to be your A value, right? The distance from the asymptote to the intercept of the graph. So it would be 1, right? Because if this is your intercept and this is your asymptote, what is the distance between this line to the intercept? It's just 1. So again, the A value is not always the y-intercept. It's always, think of that as your stretch or shrink, right? The stretch or shrink. And we can find that by finding the distance between the line and the intercept. Yes?
So your A value is always going to be like the same thing as whether or not you're shrinking or stretching? Like the same value as so like, you know how you went up 1? So then your A value is also going to be 1?
No. Again, it's not always, it's because the up one, the transformation and this distance is equal, but it's not always the same, right? So for example, if you have this, let's say that's our exponential. And then this is, let's say, this is y equals 0. Okay? So there's no transformation for like the shift up and down, but we know, let's say this is 3. Okay? So therefore, there is no transformation. Right? We don't say up 1 or down something, but we know that A is equal to 3 because the distance from the horizontal asymptote to this intercept is 3 units. Okay? All right. So now, okay, let me write the equation here. All right, so we can write this as y equals, I'm just going to write the general form, a to b raised to x, and then plus 1. Okay, why did I add 1? Because I know that the transformation is up 1. And I know that a is 1, so I can plug in a as 1, right? So y equals 1 times, I can put that as b to the x, then plus 1. Okay. We're not yet done. We're going to solve for the base, right? Okay, you may or may not put the 1 because I know 1 times this is just b to the x, right? Okay, so let's try to use a point on the graph and use that to solve for the base, okay? So which point is easier? Just give me any point on the graph.
15, 0,
Okay. Don't give me big numbers. Let's use
1, 5.
okay, 1, 5. Okay, let's use 1, 5. 1, 5. Okay, because you can use 0, 3. You can use 1, 5. Let's try something that has a value for x and y. Okay? So if we're going to use 1, 5, then this is our x, this is our y. Okay? So we're going to write 5, because that's the y, equals b to the power of 1 plus 1. Got it? Okay, so what is b to the 1? It's just b. So I can write this as 5 equals b plus 1. So minus 1, minus 1. So what is the base? 4. So since the base is 4, then we can use that to write the final equation. Got it? So what's the final equation? y equals 4 to the x plus 1.
Is it possible that we just put in like 3 points into like a table?
Yeah.
And then we just do
The regression.
y sub 1.
Correct. Yeah.
That's how I'm gonna do it, 'cause I don't
Okay,
understand
so if you don't understand this, Rowan has an idea, okay? If you know the points on the graph and you can determine at least 3 points and use the regression model, right? You can create a table and put all the points on the table and then use the regression. It's going to give you the same equation, okay? Right. You have any questions? Yeah.
I thought we kind of already determined that the x,
Yeah, we just used 1 point on the graph so that we can solve for the base.
so that as a
No, it's not always 1 because we also have other points where x is not equal to 1.
okay, so whenever we plug it in, it's not those things literally
No.
y actually equals that, or
No. We're just plugging in 1 point, but we have a lot of points. Okay?
that's just to find base.
Yes.
Okay.
Yes. It's just a way for us to find the base. Yeah.
Like you said, the guess thing with the points, we do that on the there's one of these instead of showing all that work.
As long as you can create a table and you show the table on your paper. That's fine. Okay. All right. Let's have this, and I know you can just put this on the table, and then what is our regression model? Who can give me the y regressed against, or the tilde icon or squiggly?
Forgot the sub 1.
The general form.
So do we have to do the squiggly? Is
Yes.
it only for the ones with the graph?
For the
Like
table.
red table?
Yes, and then a, b raised to x. Regression and decay. It's going to be the same regression model. It's just that if it's decay, then the base is between 0 and 1. Okay? This is the general form of the regression. Again, if you have a subscript, you have to use the subscript. Okay? If there's a subscript 1, you have to use y1. Y sub 1, x sub 1. Do you want me to do that on the graph, or do you have the answers already? You have the answers already? Can you tell me the A and the B value? Give me the A and B first. What is the A? 120? 45? Okay. 125. Okay. And what is the B value? 0.20? Yeah, that's the same thing. 0.2 or 0.2. All right. What is 0.2 in fraction? 1 over 5. So I can write this as 0.2. That's fine, all right? You can write it as 1/5. Okay, so I can write this as y equals 125 times 0.2 to the power of x. Or y equals 125 1/5 to the power of x.
I have a question about the graphing calculator.
Yes.
Okay, how do I end up getting the numbers? Once I type in the table, what else do I type in to get it?
What? This one. Any question? Any other questions? Given this table, you're not. You just have to write the equation.
Wait, when I type it in, that's an error.
You put the subscript.
Oh,
Yes.
right here.
Yeah. Any other questions? How to use the table? How to create the table and put this on the Desmos.
I'm ready for this test.
You ready? Okay. All right, I'm gonna give you 5 more minutes.
Wait, come on.
Yeah. Yeah. I'm gonna start the timer. If you have any questions, use this time. Okay. 5 minutes, and then we can start with the quiz.
I'm already ready, Mr. Can we go ahead and start?
Even when I put in the one, it's still. Do I need to take out the one for
The X. Yes. You can put it for both.
I'm nervous.
Okay, so
No, guys, I got reminded of it.
it's gonna be let me